Hello, everyone. Hello, good morning, good afternoon. Thank you for joining us today. Okay. Well, hi, everyone. My name is Alize, and I will be today's webinar operator. Welcome to today's webinar by PHCBI, titled From Reactive to Proactive, How Predictive Analytics Can Help Lower the Cost of Your ULT Freezers, and presented by Isaac Blanco and Joe Laporte. Before we get started, I would like to go over the format for this webinar. Isaac and Joe will give a 40-minute presentation. After the presentation, a question and answer period will take place. All lines will be placed on mute during the presentation. You may post written questions during the webinar by using the question box in your Zoom panel. After the presentation, all questions will be answered. I am now happy to introduce the presenters. Joe Laporte has been the Chief Innovation Officer at PHC Corporation of North America since 2022. He has over 30 years of international experience in cold chain management and ultra-low temperature refrigeration, and deep expertise in engineering and product development. A dedicated member of the PHC Corporation of North America for 28 years, Laporte has played a pivotal role in advancing the company's cold storage technologies and lab equipment innovations. He has served on the Energy Star Stakeholder Committee for lab-grade products and currently serves as a voting member on the NSF committee that defined the American national standard for vaccine storage. Isaac Blanco is a biologist with robust experience in lab products, medical devices, and services. He has been working with some of the lab and medical devices industry leaders during the last 15 years and is now the life sciences product manager at PHC Europe, mainly taking care of cold storage technology. Joe and Isaac, you may begin your presentation.
So, Lise, it's nice to hear someone pronounce my last name the way it's meant to be. I'm glad you're French in this case. Hello, everyone, and thank you for joining us today. I'd like to start off with a term we've all heard over the last several years, and that being predictive analytics. But I'd like to take it from possibly a different perspective than you may be used to. So traditionally, biorepositories would conduct their PMs on their equipment and hope that nothing breaks. So they don't have to enact their emergency response plan. And this is where predictive analytics comes in. So what is predictive analytics for those of you that aren't aware of it? I'll get into that a little bit. But why it is important is that today the therapeutics are becoming much more increasingly complex and expensive. And the cost of product loss has never been higher. And you all know that if you're maintaining samples within a biorepository, that those samples that you're storing in your ultra-low freezers are priceless. So every deviation in the storage performance, whether it's due to component wear or temperature drift or unforeseen issues, can really jeopardize the integrity of what you're storing and the products inside those freezers. So predictive analytics can help you prevent these risks by continuously monitoring equipment performance, identifying the early signs, and allowing you to enable proactive maintenance rather than scheduled maintenance. So by keeping them at peak efficiency, it lessens the opportunities or the chances, I guess is a better term, for you to not have to enact your emergency response plan. But there's still a long way to go with all of this. So I'd like to take it from, like I said, a slightly different perspective. So today's predictive landscape, for any of you that have monitoring systems that involve predictive analytics, they're usually focused on terms such as your health score or AI-driven analytics or compressor health scores or data from similar products to discover trends, and that's often where the AI comes in. I can tell you from a manufacturing perspective, from a company like ours that's been producing lab equipment for over 60 years now, that no new products, even of the same model, are identical. Your usage patterns will often change. How the product is used as you're in adding or removing product can really change your energy performance and performance profile. So if any of you have had false alarms, I would suggest that maybe a lot of them are related to that. your energy profiles aren't necessarily going to be lower as your system is just running idly without anyone entering it. So when we look at ultra-low freezers and predictive analytics in particular, one of the most common problems or products monitored are ultra-low freezers, of course, due to their high-value contents, as I mentioned. But when an ultra-low freezer fails, it can really be compared to having a heart attack or a person having a heart attack. So common causes of freezer failure are a compressor or engine is failing or isn't running properly, or the freezer suffers an oil restriction and warms up. So if you're not familiar with an oil restriction, you might be familiar with the symptom of an oil restriction. That's when you may have a freezer where everything seems to be running properly. You can hear the compressors or engines running, and you're not really sure why the freezer is warming up. And often, if you call the manufacturer, the advice you get is, well, just warm it up to room temperature. Move your product, warm it up to room temperature. Let it sit for a day or two, and then start it back up again. And then the freezer seems to be fine. There's really, from your perspective, no cause that causes that. But that's often an oil restriction. Or to put it in human terms, it's like cholesterol blocking the arteries of your freezer that can often cause that situation. So predictive analytics can help you determine if your freezer is prone to having a heart attack, but really the question is, what's the best method? So, using a human analogy, I still think, and from my own perspective, I think that predictive analytics are still in their early days. We all like to think that everything is leading edge and cutting edge, especially when we're adding AI elements to it. But if you look at it from a human perspective, years ago, back in 100 years ago, heart attacks were typically diagnosed by using a stethoscope or a blood pressure to determine whether you might have a heart attack. So the challenge from that is that it's really a rudimentary process to determine whether you're going to have a heart attack. But today, 100 years later, we have all sorts of different methods for diagnosing this, such as coronary arteriography or CAT scans. And those are more obviously a better method for determining whether you're going to have a heart attack is you can image your blood vessels and your blood flow and x-rays. So there's all sorts of methods of doing that from a human perspective. But when we look at predictive analytics, again, staying with the comparison from a human perspective, the internal sensors would be your contrast dye, and you have external sensors, which are x-rays or CAT scans. So same with ultra-low freezers, your internal sensors would be your temperature probes, and your external sensors are typically a power monitor, an ambient sensor, or a door opening sensor. So using that same analogy, what would be better? So let's just say from a human perspective, you could go to your cardiologist and they would instantly hook up some internal sensors that you have in your body. They could monitor heart condition, major arteries, organs, skin temperature, all sorts of different things using sensors that are already inside your body. Well, we all know that none of us are born with sensors inside our body, but if you had all those different points of things you could monitor inside your body, we all know that the more data points you get on any analytic, the more accurate the diagnosis can be. So what if your cardiologist, who understands the working of your heart better than anyone, can give you instant advice on what to do to prevent a heart attack related to the data gathered if they were able to gather all sorts of information from internal sensors. So again, using the same parallel, from an equipment parallel, a compressor operating temperature can be likened to a heart rate. Evaporator and heat exchanger temperatures, these are all components within your freezers, your ultra-low freezers, could be likened to arterial blood flow. Condenser inlet and outlet temperature, your skin temperature. Refrigeration component temperature, your organ temperature. So I'm not going to go through this entire list, but hopefully you get the idea. And from a cardiologist perspective, we all trust our cardiologists. And since we're a manufacturer that's been manufacturing ultra-low freezer for decades, we're the expert to know what all of these sensor points would actually mean. So to carry that further, what if your if the monitoring was built around the product that you were monitoring? So this is what we're capable of doing as a manufacturer. we can embed data points that most external monitoring systems are not capable of doing. So, as I mentioned, a lot of external monitoring systems, when you're looking at those, they'll come in, they'll do installations of different sensors, maybe 3 or 4 sensors external to the freezer itself. Well, during the manufacturing process, because that's really the only time you can really embed all these sensors within the freezers, we add on some of our products, we add up to 48 internal data points. So we're able to monitor all sorts of things like your temperature of all the different components in the refrigeration system. We can monitor power. We can monitor fan speed. We can monitor all these different things. So what that can give us is proactive guidance built around collective years of product experience. We know what a freezer should be doing, and we also know what a freezer shouldn't be doing if it's not healthy. So the whole purpose of the monitoring system should be, especially with predictive analytics, it should be purpose-built and not from off-the-shelf components that kind of meet an application. So what we get is a freezer or an ultra-low freezer in our case from several of our models that are already at launch, and they're standard features within the products, and they can give us expanded data points. And it also allows us to scale automatically. Some of these with biorepositories, you may see some units here like our twin cool freezer, or our twin cool refrigerator, and our incubators, which you may not be familiar with, but you probably are familiar with our ultra low freezer lines, which you'll see on the left here. So we're able to scale automatically without having to add new sensors and new features onto the freezer. They're already built into them. So our solution is what we call LabSwift, which is our IoT solution. So what we're able to do with LabSwift is monitor all of those internal data points continuously. It's a plug and play system. You can see from the image here, there is a USB port on the bottom of the displays on most of our newer freezers, and you're able to plug directly into that. And that will send telemetry data to our user interface, so it'll be able to determine whether that freezer is running optimally or not. And again, it scales. So to look at it from another perspective, we have a feature within that called Health Check. There's no machine learning required in this case because our knowledge is built into it from how ultra-low freezers should operate, especially our ultra-low freezers. Now we can monitor other freezers as well, but the heavy predictive analytics, the ones that give us the most leading edge information, is built into our freezers. So we will look at ambient temperatures, compressor speeds, deviations, and we will transmit those results as corrective actions within the user interface platform. Of course, if there is an alarm condition or the freezer is not performing properly, it will send you an automatic notification either by voice or text or whatever method that you prefer to get your messages. We all know that we all get lots of texts and sometimes messages can get buried, but it can also give you a voice notification so you don't miss anything. So what it will do is if it's hooked up to our freezer, it's monitoring all these different points, and it will give you a list of things you should do to maintain that freezer properly. So what that does is it gives you peace of mind as far as making sure that that freezer is running properly, but it also can decrease your cost of ownership because I know many of you will have regular PM scheduled. Well, if there's too much ice built up in this freezer, we can do this, or we have to defrost this freezer and move the product. So it's better if you have a system that will tell you, pay attention to freezer 642, 17, 63, instead of looking at the whole mass of all your freezers and saying, I have to do PMs on these, even if it's not needed. So that's what our system offers, and it will tell you exactly what you need to do to try to bring it back into that healthy range you see in the green here. And of course, the user interface will give you a view of all of your connected assets very easily using the interface. And you can, of course, drill down to the affected units that are coming up yellow or not as happy as you would expect them to be. So beyond that, we're seeing a trend in the industry of real-time performance monitoring. And what I mean by that is a lot of you, when you receive a new freezer or yearly, or sometimes later, depending on what your SOPs are, when you get a new freezer, you'll typically map it to say, okay, I have a plus and minus 5 degree uniformity requirement at all points within this ultra-low freezer. And during that IQ, OQ, PQ, or performance testing that you're doing on the freezer for validation, you can determine the warmest spot and the coldest spot. And what LabSwift offers is two additional ports where you could connect external temperature sensors. So you could put one sensor in your warmest spot, one sensor in your coldest spot, and beyond the predictive analytics, you could continuously monitor the uniformity of your freezers. So you would be able to determine, well, if my temperature uniformity requirement is plus or minus 5 degrees, and I've got so much use or I've got so much frost inside this freezer that I'm running outside of that spec, then you could take proactive action just based on that information. So what's key here is that often with validation, you're doing it once when the freezer is new, but conditions will change, your usage patterns will change, how you stack product inside that freezer will change. And what this gives you is the opportunity to give you real-time monitoring of exactly how that freezer is operating and whether you're staying within specifications or not. And if you're going outside of that, it gives you the opportunity to react to it rather than wait until your next validation of the freezer to find out that you may be outside of spec. So that gives you an additional peace of mind related to what your monitoring system is capable of doing. So often, as I mentioned, PMs are performed on freezers based on a set time period, and this can add unnecessary stress to the freezers. We all know that when you're scraping ice on freezers or trying to remove ice, is that you're keeping that outer door open for a long period of time. Now, our freezers have insulated inner doors, so it's not as stressful. But often with ultra low freezers, while you're spending that time scraping the doors, lots of warm air is entering that freezer. We all see that with the frost patterns that are hitting the floor. And that's going to put some stress on the freezer because it has to deal with that additional heat load that just entered the freezer while you're doing the PM. So that, of course, can increase your cost of ownership as cleaning every freezer on a set schedule adds to your labor costs and it puts stress on the freezer. So the key is that our LabSwift system can identify problematic units and you can pay attention to the ones that are not behaving the way you would like them to, and that can reduce your overall cost of ownership with the system. So what we're offering here is a much more advanced system that comes from the manufacturer of ultra-low freezers, as we are, that can give you all of these assets and predictive maintenance. And as I mentioned, we're still not at the point where everything is perfect. There's lots of things that we're learning as we go. Something that AI can't necessarily give us. It's AI is only going to know what it knows. And we're taking all of our expertise across all of our employees and adding this to LabSwift system. So if you're a subscriber to LabSwift, all of these updates on all of our predictive analytics as we move forward into the future and we learn new things become part of the system without any additional charges to you. So that's kind of how we set up our system to be able to operate for you, what LabSwift offers, and how it can save you money and hopefully help you sleep better at night without knowing you have to enact your emergency response plans. So with that, I will hand it over to Isak. If there's any specific questions, certainly drop them in the chat and we can answer your questions as they come up. Thank you.
Thank you very much, Joe. Now, in addition to the predictive analytics and the LabShift system, it is mandatory to clean, as Joe said, to clean and defrost regularly the freezers. Now, in the next slides, we will show you how PHCBI. No, please come back.
Okay.
We will show you how with the PHCBI frostless freezers you can save money, you can reduce the cost, the return of investment, and how we can help you to clean and defrost the freezers. First, before that, I would like to remind you that the most important asset in your lab is your samples, are your samples. Okay, these are critical for your daily work, and storing them in a stable and safe environment is critical for your results. Okay, so let's start now with the some common use issues that we face in our daily meetings. Okay, one of the main pain points is that the freezer does not get that cold. So this is very important. This is really critical because if the freezer doesn't achieve the set value, this means that the samples inside, again the most important assets, will be under risk. So keeping and storing your samples in a stable, high performance freezer is very important. And sometimes this is caused, the root cause of this is the frost, because the frost never give up. So the frost continuously grow. If you don't clean the frost in your freezer, will at the end of the day can will affect the performance of your freezer. Okay, so because the frost will affect critical areas like the door gasket, the doors themselves, or the door latches. Okay, so the frost continuously grow, and then if you don't clean, you will have issues with the freezer. So in the next slides, please, Joe, next. Uh, in these slides, we will show you how to prevent and how the PHCBA frostless freezers will help you to reduce the cost of ownership and save time in this and inconvenient cleaning of the freezers that nobody wants to perform, and it's sometimes very tough. Okay, with the frostless freezers, you can see here there are three manual steps. Okay, step one is the cleaning of the inner doors. You can see that with the previous models, okay, standard models, depending on the quantity of frost, you will need up to or more than 10 minutes. Okay, with the frostless freezers, you need three times less. Okay, with around only 3 minutes. In the step two, you will save around 1 minute more, okay, when you need to defrost the door gaskets, the inner door gaskets, okay. This is also very important because the frost usually grow in the areas of the gasket because there are a lot of points that grow the frost and prevent or make very difficult to close the inner doors. Also, the step three that also it is very inconvenient. It's the wiping down of the melt frost water. This is also really this is very inconvenient because you need to put dry clothes or towels or paper on the floor and clean all the water that are melted from the frost. So the more frost you have, the more water you need to wipe. So this is the three more inconvenient steps, and you can see with in these three steps you will save plenty of time with the frostless freezers. In the next slide, please, we made a calculation, okay, an estimation of how many time you can save with a frostless freezers versus the previous model. We can make a calculation of 6 units, but you can see here in the table by unit. So by year, for example, in the previous model, you need around 160 minutes, okay, to clean and defrost the freezer. With the frostless model, you only need 42 minutes, so you are saving around 2 hours by freezer. Okay, in this business case, or in this case, we are speaking in 6 units, so you will save around 12 hours of your working time. So imagine multiply these 2 hours by freezer by tens or hundred of units that you have in your facility. You will see how many time you will save, and this is not only by the quantity of time you are saving, but also that you can use this time for more valuable tasks. Okay, so for your scientific research, for your experiments, not for cleaning the freezer. Okay, so you are saving time for your valuable things. Okay, so this is the most important thing. Okay, next, please. Okay, how can we help you, or how can we prevent the frost buildup in your freezer? With the frostless freezers, there are three main strategies. Okay, the first one is the new inner doors. Okay, we have designed a new inner doors with VIP vacuum insulation panels. Okay, to prevent the frost on the surface because they are very wide. It's around 80 millimeters wide. Okay, they are very well insulated. The second is the new design of the gaskets. Okay, the inner door gaskets. Okay, they are designed with a heated frame. Okay, to prevent the frost on the gaskets. And the third one, the third strategy is the new design of the latches that will break any frost on the inner door system. If you compare with the previous models, you can see that there are plenty of frost in the on the critical areas like the gaskets, the door latch, and this frost again never give up. So it constantly will grow and create more frost on that area. This frost could affect the door opening and even the performance of the freezer, the temperature management, which is the most important thing. If the temperature management is affected, then the samples will be affected, and this will create problems with your samples. Next one. A part of the reduction of the prevention of the frost build-up, there are some other benefits of the frostless freezers. The most important here is the power consumption. Okay, so in this case, you can see with the frostless freezer, the 700 liters version, there is only 6.9 kilowatts hour day. So this is a very low power consumption for a 700 liters model. Okay, this is because the frostless freezers work with hydrocarbon refrigerants and inverter control compressors. So in addition to the low power consumption, the inverter control compressors will make a more stable temperature, okay, inside the chamber, okay, because it avoids peaks and valleys of the previous on-off compressors, and also the samples consequently will be more stable. Okay, so here you can see the four main benefits of the frostless freezers. The first one that I already told you is the reduction of frost build-up. Okay, so you will save time cleaning the freezers. Okay, the low power consumption is the second one. Okay, with the use of hydrocarbon refrigerants and inverter compressors. The third is the protection of the critical parts. Okay, again, if there is no frost on critical parts, this frost will not affect the closure and the temperature management, and the samples will be more safe and stable inside. Okay, and the third one, a part of saving money with the in the energy bill because you have a very low power consumption, you will also save money with the racks because you can use the legacy racks or the racks of the legacy models. Okay, we are Sanyo and Panasonic. Don't forget that. Okay, so we have a long story with freezers. So you can use your current racks from the Sanyo and Panasonic models. You can use them in the new frostless freezers. So you will save money with the energy bill, and you will save money with the racks. Okay, so these are the four main benefits of the frostless freezers. Okay, Joe, I think you have to take back the control. Thank you very much.
Thank you, Isak. So just to recap, we have two items that may help you here between our frostless freezer. Don't forget our flagship freezer, the 702 VH, which VHA, which is now available in dual voltage that many of you are already familiar with and many of you rely on for your biorepository needs. We also have recently launched a new twin cool freezer that uses all HC refrigerants, natural refrigerants, that reduces the energy consumption as well. So, and we also have our VIP Eco Smart freezer that allows us to has additional features on it, such as door locks and access control through keypads or um, optional ID cards or facial recognition, which is a standard feature on that freezer. All of these freezers have the predictive analytics built into it that allow you to connect LabSwift. But as I mentioned, it is a feature that we are embedding in all of our products. We can also connect LabSwift to our existing product lines, going way back several generations. Although the latest generations, the 702 and 703 versions, and our new Twin Guard and the frostless, all have the predictive analytic features built into them so that we can help you manage your fleet and be able to maybe sleep better at night. So, with that, I think we'd like to conclude this presentation and thank you for joining us. And if you have any specific questions, certainly let us know.
Thank you for this presentation, Isaac and Joe. So this concludes the presentation segment of the webinar. As a reminder, you may post written questions by using the question box located in your Zoom panel. So we will give participants a minute or two to submit their questions. We do have one question here. Where do you see the future going with predictive analysis? Predictive analytics.
That's a good question. Where is the future going? I think I mentioned a bit in the presentation that predictive analytics is something that we're seeing really start to ramp up. We have the ability to connect to building monitoring systems with some of our outputs on our products. That's a recent introduction that we've added. So there are a lot of customers that want to be able to build their monitoring into their BMS. But where I see it going, as I mentioned in the presentation, I think what we're going to see is, I'll use an example. Early in my career, I was a field service technician and for several years, and I would see that often we could diagnose ultra-low freezer issues from just about any manufacturer by measuring these temperature points, at least the ones we had access to, usually down in the compressor area, or be able to monitor the compressor itself and be able to do a diagnosis without accessing the refrigeration system itself. This had to evolve because it became illegal in many countries to tap into a refrigeration system purely for diagnostic purposes, so we had to find other methods. Now, those methods are what we're incorporating into LabSwift now is, okay, this is what we've done in the field to determine certain situations. We'll embed that into the predictive analytic part of LabSwift, but there's still a lot of different features that or different things that we're still learning when a freezer fails. It's rare for us to have a freezer failure, so it's some of those things that we have to catch as it happens, and then we do an analysis of it and say, what did this tell us about this freezer's operation? Could we have predicted this happening 6 months, a year, even more in advance before something happened to the freezer? So there are a lot of things that those of us within our factories, our engineering groups, and for us and our product support teams, cumulatively is over hundreds of years of experience that we're bringing into the system. So in the future, I think we'll be able to refine predictive analytics much more tightly than it is today, and really give us a future where hopefully, if all goes well and we're able to pull all this information, be able to see freezers that are starting to get sick before they even show any symptoms at all, at least outward symptoms. So that's where I think it's going. But to do that, we need to be able to embed all these sensors. So if we learn that there's something else that we need to embed within the system to be able to give us better analytics, we're able to do that because we manufacture the freezers, and then we can make sure that that gets presented through our user interface on our monitoring system. So I think that's where it's going, is as we learn, we'll be adding more features as we go, and I think that's where the industry is going. But thank you for the question. That's an important one.
Thank you, Joe. Rachel is asking, how are the analytics validated to ensure relevance to freezers in different use conditions?
That's a good question as well. So, for example, we know that if you've just opened the door and accessed, you pull the rack out. Sometimes we have customers that'll go as long as 5 minutes. Not recommended, but they'll take their time. They'll look through the boxes and they're trying to find one particular sample. Then they'll put it back into the freezer. Obviously, the freezer is going to start ramping up. It knows the door's been open and sees the temperature start to rise as that box has been pulled out. And it's going to start ramping up to make sure um, that we're not getting into a situation where it's starting to pull more energy, and does that cause a failure mode, or does that cause it to be diagnosed as a sick freezer? So we take all of that into account. We know the usage patterns. We know that the freezers themselves have automatic processes they go through just to be able to keep that freezer running as well as possible. These are all in the background. Most people aren't even aware of. A lot of servicers are, but end user customers don't see what the freezer is doing automatically to try to avoid issues in the future. So we take those into account within our programming for the monitoring system. So we're also 21 CFR Part 11 compliant with our data. So for all of you that are following FDA regulations or following within FDA, our monitoring system is compliant with those regulations. So that helps you as well, I think, in many cases. So it helps you get through an audit and making sure that the information that we're presenting and that you're tracking is an auditable event that you can keep track of. It will also allow you within the system, if it notices there's an error or there was a power failure or something went into alarm, the system allows you to acknowledge those within the user interface. So it keeps track of everything that you're doing. You can monitor and record the events related to if you did maintenance on the units. There's a lot of information that we provide within the user interface. And if you're interested in the system, we can certainly make sure we get the information in your hands and possibly do a demo to make sure it meets your needs.
All right. Stella asked a few questions. So, does the sensor determine the coldest and warmest spots with the freezer, or the user needs to identify this through freezer mapping?
I would suggest that's a very good question. I would suggest that you would determine it through your freezer mapping. We kind of know where the coldest spots are in our freezers. Obviously, heat rises, and then we might have something in the back corner, and the coldest is in a operating freezer might be the lower rear corner. But I would suggest just so that you're able to we can give you ideas of where that might be, but I would suggest that so that you have full traceability is that you would determine those through your validation protocol and say, okay, we've confirmed that yes, these are the warmest and coldest spots when we did our validation. Even better if you do a simulated PQ with your products or simulated products that you're putting in the freezer to make sure that pattern doesn't change. But I would suggest, and this is my own opinion, is that um, once you've mapped the freezer and you know that it's not going to be different than the freezer sitting next to it that may have a different profile. No two freezers are exactly alike. So by doing that and determining your own warm and cold spots and then putting your sensors there, you're able to demonstrate this is what we identified during validation, and this is where we put the sensors to make sure that we're staying consistent with the temperature ranges that we require. Good question. Thank you.
And there's quite a few follow-up questions. Maybe I should read all of them. So please clarify, did you imply cleaner out freezers periodically will not be required when the PHCBI freezers are used? If so, what aspect of the predictive analytic makes this possible? And I'm going to continue the comment from Stella. Common issue questions. The positive aspects of the frostless freezers are really great. However, in an environment with limited resources and with regards to conserving cold, when there is an electrical outage, which freezer holds cold temperature the longest, frostless freezers or those that build up frosts? So a few
Okay.
questions.
About the first question, yes, you need to clean the frost always in each freezer. Is impossible. So it's nothing you can avoid because frost is coming because you open the door and the air with humidity is coming into the chamber. So it's nothing that you cannot. It's impossible to stop. Okay. But with the frostless freezers, what we are doing is preventing that the critical areas in which the frost is usually growing or building up, like the inner doors or the gaskets, we prevent or we reduce this frost. Okay, so how this is linked to the predictive analytics? It is not a direct link. Correct me, Joe, if I said something incorrect. Uh, but if you feel, for example, the LabShift system will tell us or tell you that, for example, the compressor is running at higher speed or the temperature has a deviation, and then with this, we'll tell you that the system is not healthy, the freezer is not healthy. And then with this, you need to go to the freezer and check, for example, if this is because there is frost on a door gasket that is preventing that the door is closing tightly and the air is coming. So there is not a direct link between the predictive analytics or the lab sheet will not tell you, oh, I have frost. The freezer has frost, but the performance of the freezer will show you that there is, for example, frost or on other issue. And the good thing in this predictive analytics is that is the prevention is before the issue happens, the problems happen, you can see, you will notice that the freezer is suffering or there is something happening with the freezer. So it's much cheaper and better when you make something in before or make a maintenance or clean the freezer or clean the filter. Sometimes also it's the filter. The LabShift will tell you, oh, the filter is clogged. So or in a couple of weeks the filter is clogged, and then you can clean the filter and the performance of the freezer is coming back to the standard. So this will help you to prevent these any future issues, and the less frost in the freezer will also keep the freezer in a good shape. Okay, so as again, because the frost will all never give up, so when you have a frost spot in a freezer, probably this frost will grow and then you can have problems. So cleaning the frosting the freezer is always a good procedure. The second question is about which freezer holds the cold temperature the longest. Again, having frost inside a freezer in critical areas will affect the freezer and will affect the performance because, for example, if you have four inner doors or two inner doors and one of these inner doors are not well closed or closed tightly, this will this cold will escape from the chamber. Okay, so there is no we can say efficient insulation if there is frost between the inner door and the gasket or the frame. Okay, also it's not only about the inner doors and so on. It's also the insulation of the freezer. Our freezers have we call BIP Plus, vacuum insulation panels plus, which has a very low thermal conductivity. So we think in an integral system that prevents the frost and also insulate the walls and the bottom and the top of the unit. Okay, to prevent that the temperature change. So in a power outage, there are some tasks that you can do. Before that happens, it's better to have racks or boxes inside the freezer. So an empty freezer is the worst case because the air is not doesn't keep the temperature very long. So don't have a lot of empty space inside the freezer. Of course, don't open, have the freezer clean in a good shape, and also if you have problems with power, it's better to work at -80 better than -70, because then you have longer times to achieve the critical point of -65.
Thank
Thanks,
you.
Isak. If I could answer the other question that came in on this. The question is there a possibility that LabSwift will work on any other types of freezers from other brands? The answer to that is yes, we're able to monitor the temperature inside another unit. So as I mentioned, we have the ability to add 2 extra temperature probes or 4 to 20 transmitters onto LabSwift, or different types of inputs that customers may want, such as for CO2 incubators, we can do a CO2 sensor. There's all sorts of things we can do, but typically if it's hooking up to the freezer itself, we prefer not to do that because we don't want to interfere with another company's freezer or what they're doing with it. So we can monitor the temperature and present that to LabSwift, but our focus, because our freezers are built different. A lot of our freezer designs are things you can't see. It's not the front door with all the funny panels and beating hearts and different things like that that make our freezers different. It's all the stuff you don't see. And so our freezer designs are different than other manufacturers. So because we're experts in our freezers and how we design them or how we have designed them for decades, we're able to build the predictive analytics based on that. And so the answer is yes and no. We can monitor other organizations or other companies' freezers, or even going way back in our history, 20 years ago, 30 years ago, we can still monitor those older freezers that don't have those external sensors built into them. But when it comes to competitive products, we can monitor the temperature, but that's kind of the limit that we can do on someone else's product.
Thank you both. We've got a couple more questions. Regarding the IoT sensors plugged into the USB port, how is the information transmitted to the receiver? We work in a facility where IT security doesn't approve information exchange over Wi-Fi to cloud storage. Would there be a receiver that is connected to a PC where we would see the data in a program?
That is a very good question. What you're talking about is an enterprise solution. We do have 2 methods. We don't have that currently. However, as I mentioned, we're able to send data from our freezers to a BMS. And there's a lot of things we have in development. We are working right now on alternatives to the communication protocol, recognizing that some customers have IT security that does not allow them to use the Wi-Fi signals. We do, however, have position papers, and we do work with IT professionals to show them this is what we're doing. We're not interfering with your security of your system, but there are still cases where customers will still have, or the IT people are too busy to be able to look at the security. So we are looking at solutions to that. We also have a hardwire option on this system as well, where you can either use Wi-Fi signal or you can hardwire through a Cat5 cable, I believe, to be able to connect that system.
Or, Joe, also maybe they can connect for example, the Vipeco smart freezers to the MTR Modbus. That's
Yeah, the Modbus connection, yes.
so we have
That
an option also that is an accessory that is a Modbus with a LAN port or a Ethernet port that can be connected by cable with using Modbus communication protocol, and the next one is the OPC. So we'll have the international, or can say universal languages.
Yeah. So we're constantly evolving and looking at what our customer feedback has been. Of course, that's very important for all of us, and making sure we provide that. So if you're looking for an over-the-air solution, yes, we are working on solutions for that. So reach out to us. We'll be able to work with you on providing that solution.
Great. And a last question. Can you clarify if the freezer needs LabSwift monitoring for the predictive models to work?
Not sure I understand the question. Could you repeat that? Sorry.
Of course, the question is, can you clarify if the freezer needs, and the word is LabSwift,
LabShift.
monitoring for the predictive models to work?
I assume the question is which models does it work on? Um, so basically, it'll work on our flagship freezer, our 702 VH or VHA, which is now available in dual voltage. So you either plug in the 115 or 220 for North American customers. European customers, of course, are I think at ESAC it's 230, 240. But also our new twin guard freezer has that ability to connect to it. Our 703, 702. So basically, most of our newer models of freezers that we've been building since, not all of them, there are caveats to that, but reach out to us if you have any specifics that you're looking at and making sure LabSwift works with it. We can make sure that you have that information. We do have documentation that shows which system it works with. We call it internally, we call it a Gen 3 product. Those are the products that connect seamlessly with LabSwift and give all the predictive analytics and all the sensors. We also have Gen 2 products, which have less sensors and less connectivity. Then Gen 1 is where we're connecting a temperature probe or competitive products or other products out there, or we're just connecting the temperature sensor. So we can certainly give you specific information on which units have what. If you either go to our website or reach out to us through information that's on our website to reach out to us, or just call us directly. I think the information on our website is within this presentation, but if not, just look for PHCBI and it'll give you to your regional office, and you can fill out the information there, and we'll certainly reach out to you, give you all the information you need.
That sounds great. I don't see any other questions.
There is a question in the chat. I don't know if we have already answered.
The question from Sylvie?
Yes.
Yeah, I think Joe answered it
Okay.
earlier. Is that right?
Okay.
That's
No?
correct, yes.
Yeah.
Okay. Okay. And
Great.
one person, Mr. David Carley, it's with the hand. I don't know if something else.
Sorry, what is the question, Isaac?
No, no, it's not a question. He has raised the hand up.
Oh, okay. Um,
Oh, I think there is no
let's
more.
see. Oh, yes. So if that person can, oh, maybe that was a mistake. But if there's any other questions, please don't worry. We will wrap up the webinar now, but we will send a thank you email, which will include the recording of this webinar. It will also include some brochures from PHCBI and an email that you can reach out to, um, which Andrea put the website and the email in the chat for everybody to see now. It will also be reiterated in the thank you email that you will receive later. So since there are no further questions, I'd like to thank our presenters, Isaac Blanco and Joe Laporte, and
Thank you
our
very much.
sponsor of this webinar today, PHCBI. And thank you all for watching today's webinar. Before we wrap up, we would like to invite you to check out the other webinars presented by ISBER and available on the isber.org website under webinars. ISBER is also pleased to invite you to its next meeting, the International Biospecimen Summit, taking place in Toronto, Canada on October 28th to 30th. Currently, there's a call for abstracts that's going on, and registration and exhibit opportunities have just been released. And last but not least, please save the date for the next ISBER Global Biobanking Congress. That's going to be in San Diego, California, USA. That will take place on May 2 to 4th, 2027, so next year. And for more information about those events, please visit the isber.org website. We look forward to you joining us at these future events and future webinars. Thank you, everyone. Thank you, our presenters. And this concludes the webinar.
Thank you
Goodbye.
very much. Bye.
Thank you.
Merci beaucoup.
Merci.